and welcome to Math World. Today we're going to talk about the quadratic formula. Alright, so the quadratic formula is just another way to solve quadratic equations. We learned a lot of other ways like factoring and completing the square, or even just looking at a graph. Remember, the solutions to the quadratic equation can be found as their x-intercepts. So when y is 0, what is the value of x? When y is 0, what is the value of x? And that's what we're going to try to do today using this formula. So this is the formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And it seems like a lot at first, but really it's not too crazy. It's just order of operations. And we can use this formula to solve any quadratic equation. And that's what's kind of cool about it. It doesn't have to have nice, easy factors or roots to get the solution. It will always work, whether it comes out to an easy answer or a kind of crazy, irrational answer. So let's go ahead and see it in action. I'm going to go ahead and make up an equation. I'll say something like 3x squared, that makes it quadratic, plus 7x minus 5 equals 0. We'll make this first one equal 0 to make it simple. Because remember, it always has to equal 0 in order for this all to work. Alright, so now that we have a quadratic equation, we can use this formula to solve for x. What is the value of x that makes this statement true? So you can see we have the a, b, and c in our formula, so we're going to want to pull those out of this quadratic equation. So first identify the a, b, and c. Remember, the a is that leading coefficient in front of the squared term, so in this case a is 3. B will be the next coefficient in front of the linear terms, in this case 7 will be b. And the constant at the end, minus 5, that's your c term. So c will be equal to negative 5. And notice I am paying attention to the signs. All right, so now that I've identified a, b, and c, we can just simply plug these numbers into the formula and see what happens. All right, so x will be equal to, and I'm not going to write the x equals 2 part until I get to the end. I'm just going to focus right on this formula. Negative b, and b is 7, so we should write negative 7. Then I'll write the plus or minus. I know it's weird saying two operations at the same time, but that is a plus or minus symbol. Then the square root, and inside the square root we have b squared. And again, b was 7, not negative 7. B is just actually 7. So I'm going to write 7 squared minus 4 times a times c. So I'm going to write 4, and I don't like to skip these steps. I start by just putting my substitution in parentheses. A goes next, which is 3 in parentheses, and then times c, and in parentheses c is negative 5. I'll extend my square root symbol there. And all of this, don't forget, does get divided by 2a. So 2 times 3. And again, I'm going to write down, I always plug in all of my substitutions first to make sure I didn't enter it incorrectly. All right, now that I have the whole formula plugged in, let's go ahead and use the order of operations to get the answer. All right, so negative 7 kind of just hangs out in the front. We can't do anything with that just yet. Order of operations tells us to do stuff inside of the square root first. Let's go for that square root. 7 squared, that's going to give us 49. Don't subtract 4 yet. Order of operations says to multiply next, so we can multiply all these together at the same time, though. Negative 4 times 3 makes negative 12, and negative 12 times negative 5, that makes positive 60, is that right? Yes, it does. Positive 60, and so we actually don't even have a subtraction sign anymore because we have positive 60. On the bottom of the division bar, we still have that 2 times 3, so let's go ahead and write that in as 6. 2 times 3 is 6. Give myself a little more space here. And so far, we've already kind of made this problem a little bit easier. I'm going to get rid of all this extra here. But let's keep going. We're not done yet. We can next do inside of the square root is the 49 plus the 60. So I'm going to write out everything. I always write it all out to make sure I haven't messed up or skipped anything. So inside of the square root, we now have 49 plus 60, which is 109. And all of this is again being divided by 6. Now, what's kind of interesting about the quadratic formula is it works no matter whether the numbers are nice, easy, rational numbers or irrational numbers. In this case, 109 cannot be square rooted for a rational number. It's not a whole number. And so this is an irrational answer. And in some cases, they'll actually allow us to stop right here. This could be considered the exact answer. I know it's kind of weird to say that's the answer because it doesn't seem like it's done, but it is. We're not going to try to square root this 109 because there's no exact answer to square rooting 109. It's an irrational number, meaning this is the exact solution. We have not rounded anything. Oops, a weird thing there. Exact solution. We can also say this is an irrational solution because of that 109 inside of the square root. And so this is technically done here. We have solved x. I know you don't like that because who knows what that number actually is. Well, let's see if we wanted to round this square root of 109, we could go find an approximate answer. So let's go ahead and keep doing that. Let's go ahead and pretend like we're going to go all the way and get the approximate answer. All right, so we're not quite done yet. Let's say -7 plus or minus, what is the square root of 109? So I'll have to use a calculator for that. All right, my calculator says the square root of 109 is 10.4 and like a bunch of other numbers. Again, that's an irrational number. It's going to go on forever, so I'm just going to say approximately, again, I'm rounding here, 10.4. And all over 6. All right. This isn't quite done yet. We still have that plus or minus symbol. And this is where it gets kind of weird, where we're actually going to get two answers. And we're used to seeing two answers in quadratics because, go back and look at our graph, our parabola will cross the x-axis twice. So there's usually two solutions here. So there's going to be a solution right here and another solution over here, but we don't know what they are yet. All right, so approximately, let's see what they would be. I'm going to write it out twice, both as an addition problem and a subtraction problem. First, I'll write it as an addition problem. -7 plus 10.4 divided by 6. And I'm also going to write the subtraction version of this. -7 minus 10.4 divided by 6. Okay, that's going to give me two answers. Remember, this was all to figure out what x could be. So x could be -7 plus 10.4. That's going to be 3.4 over 6. And I can leave it like that or try to turn it into a decimal. Either way, it's going to be an approximate answer. And actually, I should probably do the little approximate symbol, seeing how we are rounding here when we square rooted that 109. So x is approximately these. Oh, we forgot to put the 6 down there. All right, -7 minus 10, that's going to be -17.4 divided by 6. That's another approximate answer. These are approximate answers. And they're still irrational, though, because we don't know exactly what the answer is. It's approximately that. Okay? All right, so there's an example of the quadratic formula being used to find the exact solution of any quadratic equation. Let's try one more. I'll do one that maybe will come out to a rounded answer so that we can see it a little nicer. And I know we like seeing whole number answers. All right, how about this one? This one's going to be x squared minus 8x plus, let's say plus 20 equals 5. All right, now right off the bat, I kind of threw in a little loop there, as I did not set my equation equal to 0, and we said we want to solve these for their x-intercepts when y is equal to 0. Remember, this is a function equal to y. So let's actually set it equal to 0 by using inverse operation. So I can inverse operate and get rid of this 5 that's on the right side of the equation by subtracting 5, and of course keeping the equation equal, subtracting 5 on both sides. Now that's going to give me a new quadratic equation that says x squared minus 8x plus 15 will equal 0. All right, now that my quadratic equation is set equal to 0, I can go ahead and use that formula to solve it. Again, let's first identify our A, B, and C. All right, so what is the A, B, and C in this problem? Well, A is the leading coefficient. In this case, in front of that x is a kind of a hidden 1. So in this case, A will just be 1. B is going to be -8. Yes, negative. And C will be that positive 15. It's still that constant on the end of the equation. In this case, 15, not 20 because that was not set equal to 0, but 15. And now we can use those A, B, and C's to fill in our quadratic formula. Now the quadratic formula says negative B. And our B is already negative. So when we go to substitute this into our formula, it's kind of going to read a negative B, and B is -8, so -8. Yes, that is what's going to happen, and later that's going to simplify to positive, but I'm going to write it out like that just so we can make sure that we're copying it down correctly. All right, let's do the rest of the formula, and you don't ever have to memorize this formula, but if you do it enough times, you do start to memorize it. B squared, so -8 squared minus 4ac, so minus 4 times a, in this case a was 1, c was 15, and all of it's going to get divided by 2a, in this case 2 times 1. Oops. All right, let's go ahead and go through our order of operations to see what the answer to this quadratic equation is. -8, that does become a positive 8 like we thought it would, plus or minus the square root of -8 squared. Well, -8 times -8 is going to be a positive 64. See, watch out, these negatives are really trying to get us. And then -4 times 1 times 15 will be -60. And all of this gets divided by 2 times 1, which is just 2. All right, let's keep going. 8 plus or minus inside of the square root. We'll do this 64 minus 60, which becomes 4, all divided by 2. Now in this case, we are not going to stop here. You know, the last problem over here, we stopped and said this was a possible exact solution because we couldn't square root 109. But in this problem, we can square root 4. So we're going to go ahead and square root 4. So we get 8 plus or minus, the square root of 4 is going to be 2, all divided by 2. And since we were able to square root this number, it was a perfect square, this is going to give us a rational solution. We're going to have a rational solution as opposed to an irrational because we have nice whole numbers here that can, or at least numbers that can be written as a fraction as their final solution. All right, so let's keep going. We got 8 plus or minus 2. I know some of you can do this math in your head, but I'm going to go ahead and use what I did in the first problem and write it out twice as both an addition problem and a subtraction problem so I don't make any mistakes with my negative signs. 8 plus 2 divided by 2 and 8 minus 2 divided by 2. And remember, we're finding the answer to x. So our answer's here. And this will not be an approximate solution because we didn't have to round. X will be 10 over 2. Or simplified, x will be 5. Over here, x will be 8 minus 2, which is 6 over 2. Or we can say that x is equal to 3. So in this case, we had rational solutions because we were able to square root that portion, this portion of our formula up here. And it gave us nice whole numbers too, 5 and 3. That means if we go back and look at our parabola, these values will be 5 and 3. We could even, if we were labeling our quadratic formula or trying to figure out a word problem that was using a parabola, you would know that this value would be 3 and this value would be 5. And again, these are ordered pairs. They're the values of x that makes the equation equal 0. So 5, 0 or 3, 0. And if you don't believe me, we can always check it, right? We can always go back and say, hey, if x was 3, like I think it is, if x equals 3, does that work for this original equation? We'll just test it out. Is 3 squared minus 8 times 3 plus 20 equal to 5? Will that work? Well, 3 squared is 9, minus 8 times 3 is 24, plus 20. Will that all equal 5? And I do believe it does equal 5. 9 minus 24 is negative 15, plus 20 is 5. So it does work. That is a solution. And if you tried it for x equals 5, it will also work. X equals 5 will work. You'll get 5 squared minus 8 times 5 plus 20. It will also equal 5. So we would be able to check both of those. Those are solutions. And so this quadratic formula, while a little scary at first, is actually really great for getting you answers to a quadratic equation. If we were to factor this, we would have gotten these same solutions. If we use completing the square, we would have gotten these same solutions. If we put into a graphing calculator, Desmos, we'll get these same solutions. Quadratic formula will always work for easy problems or irrational, less easy problems. All right, well, that's it. Go ahead and practice it and get good. All right, I'll see you in class. Hey class, it's Mr. Bigsby with a hat, and I've got a challenge problem for you. Can you use the quadratic formula to solve this quadratic equation? X squared minus 3x minus 28 equals 0. Give you a hint, there's 2 solutions. All right, leave the answer in the comments. Later. Now for a word from our sponsor, Paper Cut Games. This week's game, King of Tokyo. This is a really cool game where the players are going to fight over this small little board of Tokyo, and you get to pick out characters. Like you could be the king, or you could be this cyber monkey, or this kraken. So you're going to pick out these characters, and you're going to fight over Tokyo. And the way you do it is very simple. On your turn, you're going to get 6 of these dice and roll them, and they do different things like attack your opponents, or they heal you if you get the heart, or you can get victory points or money. And every time you roll the dice, you get different things. And you can also get power-ups in the game, so you spend your money on this deck full of power-ups. They could maybe give you regeneration to give you more life, or a giant brain that lets you do extra rolls. But pretty much the game is a very simple game to just roll dice and attack each other and constantly fight over Tokyo. And it can get pretty cutthroat because, you know, it's free-for-all and people get eliminated from the game. But it's really cool. It's a simple game with fun art. Again, this is King of Tokyo. You can find it on Amazon, and it does have an expansion, King of New York. Give it a try. I'm Mr. Bigsby, and I approve this message.